All right, folks, we are missing Megan and Remington and Owen and Macy, right? Those four? Okay. Megan Remington, you're going to know this already. Owen Macy, you're not, okay? Before we do this section, 1-6, which is trig functions, okay? This is what makes calculus hard for the people who haven't already had trig. So like the fact that you're taking this at the same time makes this a little bit harder. So what I'm going to do is in this little blank space that you have right here above 1-6, we're going to like draw some stuff so that you guys can get caught up to speed, okay? So trigonometric functions, the main trig functions that we're going to talk about are, do they get us down into sine and cosine? Yeah, that's it, okay? All right, so we're going to talk sine and cosine. Here we go. So y equals sine of x, put a little spot there. Y equals cosine of x, put a little spot there. And y equals tangent of x. We're going to put a little spot there, okay? And we're going to graph those three functions on this page. You guys have never had this before. Megan and Remington, you've had this before because you had trig last year. You guys, we're going to catch you up to speed right now, okay? In order to be able to do this, we kind of have to know a little bit about what the graphs of these look like, and we don't know that yet, right? Okay? Sine and cosine are very similar to each other. So what I'm going to do is I'm going to write sine. I'm going to do one of those. He's going to be a little t, but he's going to go to the right, the majority, okay? Same thing with cosine, but a little bit more to the left, right? And tangent, we're going to put him right in the middle. Boop. Okay? All right. Here we go. Y equals the sine of x, all right? The y-axis is just going to be the normal y-axis, but the x-axis is going to be in radians. In radians, which you don't know what that is yet, okay? Do you know what a radian is? We talked about radians last year? Yeah. So one full circle, let's talk about a circle real quick, okay? If we're talking about the circumference of a circle, to find out the circumference of a circle, we do 2 times pi times the radius, right? So if the radius is 1 for the unit circle, the circumference would be 2 pi. So what that means is the distance from here all the way around is 2 pi, right? So it makes one full circle in 2 pi, all right? So what I'm going to do is I'm going to say here is 0, right? Like where 0 starts. I'm going to put 2 pi here. And I'm going to put pi in the middle of that. And then what's in the middle of 0 and pi? 0.5 pi, which they call pi over 2. It's like half of a pi, right? Okay, this one right here in between pi and 2 pi is called? What? 1.5 pi's, which is 3 pi over 2. I don't know why they write it like that. 1.5 pi's, but it's 3 pi over 2. That's how they write it, okay? All right, what they have found is that, and this will make more sense when we go to do trig, but just like bear with me now. The sine value. If you go and plug into your calculator 0 in for sine, like you go to take sine of 0, and your calculator is in radians. Your calculator has to be in units of radians, not in degrees, which is what most of your calculators are in right now. But if you are in radians, if you type in sine of 0, you will get 0 as a value. Great. If you type in sine of pi over 2, okay? Now pi over 2 in degrees is how many degrees? Like here is 0 degrees. 180 would be halfway through, right? And that's pi, right? Pi over 2 is up here. And how many degrees is that? 90 degrees, right? 3 pi over 2 is how many degrees? 270, okay? 0 is the same thing as 2 pi, and 0 degrees is the same thing as 360 degrees, right? Those are what's called coterminal angles. They terminate at the same spot. We'll get to all that when we do trig stuff, okay? But there's that, all right? So if I go to type in sine of pi over 2 or sine of 90 degrees, it will give me a value of 1. So sine of pi over 2 is at 1. Boop. Okay. If I go and type in sine of pi or 180, right, which 180 degrees is the same thing as pi, it will end up being 0 again, yeah? Sine of 3 pi over 2, if I type that in, will end up being -1. He goes down. And then sine of 2 pi, you want to take a guess? 0. Is at 0. So he's doing one of these, okay?
So he oscillates?
He does. He oscillates from 1 to -1. Okay? And then he continues on. So he'll keep going here and he'll keep going there. But this is what's called one full period of sine, because that's like the part that's like copy pasted, right? One chunk before he starts to cycle again and cycle again and cycle again. That's what sine looks like. All right, now let's talk about that. Okay? If we're talking about continuity, which means continuous functions, right? Is sine a continuous function on all reals? Yes, he will go left and right forever, right? So sine of x equals continuous on all reals. He is continuous from negative infinity to positive infinity, unless we do something weird to him, like make a hole in him or something, whatever. But he, just by himself, is a continuous function. No big deal. Between -1 and 1. Now, until when we get to trig stuff, we start to do things like y equals, let's say, 4 sine of x. Okay? That means he's going to go up to 4 and down to not negative 4, which means he is 8 units between top and bottom. Does that make sense? Okay? So this changes what's called his amplitude, and we'll get to that. Okay? So there's that. We can make him wider or skinnier as well, and we can shift that whole curve up, and we can shift that whole curve down, right?
What's this gonna do in the real world?
These are like sound waves, so when you change the amplitude, it like changes the loudness, right? Of more amps is more loudness, and that's because your curves are going higher, right? Your sound curves are going higher. If you squeeze in your little curves, it makes the pitch higher usually. Your frequency is higher, right? That makes sense?
Yeah.
Okay. So like this, a lot of times, this is not just for sound, but like a lot of times this has to do with sound. So like the taller the waves, the louder it is. The skinnier they are, the higher the pitch, right? Okay. So all of those things. Now, that was the graph of sine. Now let's talk about the graph of cosine, which also does the same thing. If I say and type into my calculator cosine of 0, okay, or cosine of 0 degrees, he is now at 1. He starts at 1. Okay, that's interesting. I'm gonna map out where 2 pi is. 2 pi, and in the middle of that is 1 pi, and the middle of that is pi over 2, and the middle over here is 3 pi over 2. Okay, all right.
Yeah.
If I go in radians, make sure you're in radians, right? And you type in cosine of pi over 2. You could do degrees, but you would have to do cosine of 90 degrees, right? It ends up being 0, right? What do you think cosine of pi will be? -1. And cosine of 3 pi over 2 is at 0. And cosine of 2 pi is at 1. So it is the same as sine. It's just shifted over slightly, right? You see that? Okay. This is what sine would look like if he continues on down. That's what sine, well, actually not right. This is what sine would look like from here to here if he shifted that way, right? Okay. So sine and cosine are just like shifts of one another,
So sine
right?
starts a different spot.
Sine starts at a different spot, right? Yeah. Something like that.
Wow.
Okay. 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 All right. Sine, cosine. There they are.
So
Is cosine continuous on all reals?
Yeah.
Cosine of x equals continuous on all reals, okay? Until we do weird things to him, which is fine, right? But even if I make him taller, right, like up to 4 down to -4, it's still going to be continuous, right? I would have to like put a hole in there, right, or something else, right? Okay, now tangent. You're not going to like tangent very much, okay? Tangent actually is sine of x divided by cosine of x, but that throws him and does weird things to him, okay? So sine divided by cosine is tangent. I have 3 posters over there that's like sink over cos equals tank or whatever, right? Siner over cosner equals tanner because sine divided by cosine is tangent, right? Ha. Okay.
Tanner was funny.
Woo. Okay, now here's the deal. If we look up here at sine and cosine, I'm giving you like a week's worth of trig in like one day. Sorry. Actually, in like 10 minutes, okay?
Yeah, Christ, you're
I know,
confusing.
right? So sine and cosine have what's called a period
Yep.
of 2 pi. This guy has a period of 2 pi. And what that means is that's how long it takes before it starts to repeat itself, right? That's how wide the copy-paste chunk is, right? Copy-paste, okay? Is a period of 2 pi, a period of 2 pi. Got it? Tangent.
No, it would just be 1.
No, tangent period is 1 pi. Okay? Okay? Tangent period is 1 pi. Here's the deal. I'm going to do this. I'm going to go 0. I'll go out to 2 pi. That's fine. I'll go to pi. I'll go to pi over 2. And I'll go to 3 pi over 2. And I will go to, I don't know. I will go to negative pi. I'll go to negative 3 pi over 2. And I'll go to negative 2 pi.
Okay.
Whatever.
Okay, then.
Whatever. Okay. Tangent of 0 is?
Hold on. Half.
No.
Negative.
Tangent is sine divided by cosine. What's sine at 0?
0.
0. What's cosine at 0?
1.
What's 0 divided by 1?
Still 0.
0. There he is, that dot. Sine divided by cosine. What's tangent at?
Undefined.
Undefined. Right? 1 divided by 0 is undefined. So what happens at pi over 2? He has a vertical asymptote. He has a vertical asymptote. Okay? At pi,
Oh, is it?
he is 0 divided by negative 1.
0.
Still 0, right? So he's doing this.
Thing where you, oh.
Okay? At 3 pi over 2, he is negative 1 divided by 0. So
Undefined.
he has another vertical asymptote there. Blah, blah, blah. 2 pi, he is 0 divided by positive 1. So 0 again. What the heck? So we have like a bunch of dots, right? Now, if we go to pi over 4, we could do pi over 4, right? Pi over 4 would be like this middle piece right here, this guy right here, and this guy right here, and we pick on those guys. And what will happen is this guy ends up going to 1, right? Because, look at this. This guy's value right here is the same as this guy's value right here. So it's like, it's actually the square root of 2 over 2 is what it is, right? Square root of 2 over 2 and the square root of 2 over 2. And if you take the square root of 2 over 2 divided by the square root of 2 over 2, it is 1. You don't need to know that, but there you go. So he looks like this. He does one of those, right? And the closer you get to pi over 2, he goes up without bound, so he's like up to infinity, right?
Put it on the other side.
Okay? But then over here, he goes like this. And then he does this again. He looks like, kind of like x cubed almost, right? And then he goes like this, whoop, right? And he copies and pastes himself. So same thing with negative. He has a vertical asymptote here. He has a vertical asymptote here. And he goes like this. And he goes like this. With some sectional. There you go. That's what it looks like. How many periods did I draw?
5.
5. Because this is like one period right here. The first main period of tangent goes from negative pi over 2 to positive pi over 2. Okay? Is tangent continuous on all reals?
No.
Tangent of x is continuous from negative pi over 2 to positive pi over 2 with parens because he doesn't touch, right? Okay? But he's not continuous on all reals. Got it? You could also say the same thing about like from pi over 2 to 3 pi over 2 with parens, not including those points, right? But he is continuous. That's what he looks like. What? He will never touch it. Nope, nope. So that is what sine, cosine, and tangent look like. You don't know that yet. Remington and Megan are very well versed in this, I hope, maybe. Because they drew these like nobody's business last year. Now, last year they would end up drawing things like y equals 4 sine of 2x minus pi plus 7. They would like do stuff like that. That has an A value, a B value, a C value, and a D value, right? This guy changes the amplitude, so he's 4 tall and 4 short, so he's 8 units, right, from top to bottom. The 7 is going to move the whole thing up 7, right? So he's going to start up here at 7, right, and he's going to oscillate around the 7. Does that make sense? Okay, this guy is going to change the period, right? So if he's 2, if he's 2, nope. If he's 2, that means 2 periods fill what 1 period would be, right?
Shorter.
So he's going to be smaller, actually. So from 0 to 2 pi, like if here's 0, 2 pi would end up being like here. This is where 2 pi would be. Because 2 chunks have filled that section, right?
So
Okay? And then this guy shifts him pi over 2.
The 2
Pi over 2
frequency.
to the right, actually.
The 2 affects the frequency.
The 2 affects the frequency, like the
Bandwidth.
period is what they call it. Okay, and then this guy changes him left and right,
Same thing.
right?
It is the same.
Isn't it true
Weird,
where
weird.
you use like the circle paper?
Yes, the unit circle.
That's what
Yep, you will get one of those.
I'm scared.
And on the back of that paper, we graph these guys right here. We graph those 3. Okay.
Alright.
Woo! Okay, that's where we'll stop. All right. So I don't want to get too far because this paper only has like one little bit on it. So there's that. Okay. Good, good?
Can I take a nap?
That's all. No, I have too much stuff for you to do.
No.
Okay, goodbye, people watching this video.
To do.
What?